Welcome to week 12 of our mini lectures in 7512 NSC Aviation Communication and Leadership. Have we got a surprise for you in this one? Because this is where we do the leadership case studies and you get to put all of what has been learnt in the course up to lecture 11 and you get to apply this. And this is something where it's not really me getting up and telling you all the information. This is one where you get to be told the situation and then you get a chance to do the analysis and say, well, how did the leadership apply in this situation? So what are we actually going to do in this? Well, first of all, we're going to look at a number of different case studies. And 3 of them are going to do with the National Aeronautics and Space Administration, a very, very great organisation, one of the most respected in the world, but even they have their leadership problems. And we're going to be looking at 3 case studies there. The Apollo 13 space mission, which was regarded as being a successful failure, the Space Shuttle Challenger loss, and then case 3 was failure to learn the lessons learned, the Space Shuttle Columbia loss. The next one we're going to be doing is first a study of the Deepwater Horizon disaster. We have a little numbering sequence there, but basically the Deepwater Horizon disaster occurred back in 2010 before the last of our case studies, the Qantas leadership in QF32. That is the Airbus 380 that had an engine explode out of Singapore, and it was an incredible example of a team working together to avert a major crisis. And of course, the one thing that we'll be getting you to do as students, and that's online and attendance, is to determine the lessons learned for aviation-oriented organisations. That is, whilst these might seem divorced in 4 of the 5 cases from aviation itself, the lessons learned there are exactly the same for an aviation organisation. So one of the things, for example, one of the reasons we look at Deepwater Horizon, which is the petroleum industry, is petroleum industry has the same as aviation. It has consequences of really large proportion when something goes wrong. And what we can learn is that aviation needs to look at other industries to say, if that can happen in that industry, could it also happen in aviation? So let's take a look. The first thing that we find out is we do a little bit of background as to the National Aeronautics and Space Administration. And of course we look at when it was formed and what it was setting out to do. And the one thing that we find is that it's accomplished a huge number of scientific and technological feats. They are truly incredible and they are a tribute to the leadership within NASA. But the trouble is that, yeah, there's a darker side to it, and that is that some of these achievements have been done at a great sacrifice. But there are some really valuable lessons learned, because when something's gone wrong, NASA has looked at it pretty well in most cases. And of course, the thing is that if we take a look at NASA as an organisation, its current vision is to reach for new heights and to reveal the unknown so that what we do and learn will benefit all mankind. So it's not just what they learn about scientific endeavour, it's what they learn in their own organisation. So it's not a bad vision to have, is it? The first thing we look at is Apollo 13. And this is the one that's regarded as being a successful failure. And of course, the first news of the disaster started when the broadcast was received at Houston Ground Control from the Apollo 13 spacecraft on its way to the moon. Houston, we've had a problem. And that almost became a part of the human lexicon after it happened, whenever people encountered a problem. And we know that the key things about the Apollo 13 mission was it was the 3rd of the US moon missions after the US successfully landed on the moon in '69. They were 200,000 miles from Earth when they had a flat tyre. Not exactly a flat tyre, but something like it. An oxygen tank exploded in the service module, and that was a threat to the crew safety. That is, it looked as though they could be marooned in space because there was no backup safety plan to send its craft to rescue them. And the thing is, once that oxygen tank exploded, not only did they get losses in air, but also in power generation, water generation, and heating, because it gets pretty cold out there in space, plus propulsion. And the thing is that the crew in space, plus the crew on the ground, plus all the contractors at different locations, so virtual organisations, had to find a way to get this crew safely back to Earth. And what they did in the end was they used the lunar module virtually as the lifeboat. They shut down the command module to save power, and they eventually got them safely back to Earth. So this is what we're going to look at in much greater detail. Now, this is a mini lecture, so we're not going to go into it in a great deal, but let's suppose that we just look at some of the parts of the problem. There's a shot of it launching, and right at the very top is the part that the crew's riding in, plus their support module and the lunar module. And we can see it's made up of a service module, the capsule itself, and there's the lunar module that they had. And of course, what we had was an explosion in the oxygen tank, and the graphics provided by an artist show what happened. But remember, the crew sitting where they were sitting couldn't see what the damage was. So this is a feature that we'll find with the case studies. Very often the people weren't exactly aware of what was happening. Well, then get you to work through and basically be able to come up with an overall assessment. We won't give you all the answers, but the one thing we find was NASA's transformational approach to build its space program did create schedule pressures there. The mission problem created a situational approach, which we studied in contingency leadership, where various experts contributed the overall solution, and you'll be able to identify how that happened. There was very good, strong team dynamics, but past change management and maintenance pressures to the engineering team caused the events that led to the explosion in space. That is, there was something that happened that should not have happened. But good communication saved the day. And of course, the important thing is, now remember what I said in an earlier mini lecture, that really with leadership, a lot of the study has only occurred in the last century, even though leadership has existed since mankind, but the study of it has only existed since last century. But when NASA did the investigation of Apollo 13, all it looked at was the technical issues. Didn't look at any leadership issues at all. So NASA was still learning about the importance of leadership. The next thing is the Space Shuttle Challenger loss. And this was a very sad loss where 7 astronauts were lost when the spaceship Challenger and its system exploded after takeoff, killing all the 7 crew. And the thing is that this shuttle mission was to deploy 2 satellites, but importantly, it was carrying the first civilian into space, a school teacher, Christa McAuliffe, and she was going to conduct broadcasts live to the rest of the world. So this had a lot of publicity. Media was really onto it. It was a big thing. And so that extra publicity really emphasised what a problem it was. And in the end, the immediate cause was the O-rings in the solid rocket booster that leaked hot gases into the main structure and the fuel tanks. And so, what do I mean by that? Well, here's a shuttle on the launch pad. That big tan tank in the middle is the main fuel tank with liquid fuels. But those 2 tubes by the side are the solid rocket boosters. They're like a straight skyrocket. That is a solid fuel. Once you light it, you can't switch it off. Whereas that central tank feeds fuel to the space shuttle's engines. So it means you've got those 2 types. Now look at the amount of fuel. 1,458,386,000 litres of liquid oxygen in the front of the tank, and then you've got liquid hydrogen in the back of the tank. So doesn't it take brave people to sit in a space shuttle with all that explosive there? They're truly brave people. The shuttle itself, and then the solid rocket booster and the way it's broken down, and the O-rings that are in between. And we'll be taking a look at all the things that contributed to this disaster. NASA was at a peak, but they'd had their budget cut back. And US Congress said, you've got to pay your own way. And so they had to look for different customers, and the customers put pressures on. And NASA had to try to meet all these different needs with a reduced budget. So shortcuts were taken. That happens in any modern organisation. And despite all the successes, it was so successful that people just went ho-hum, another launch into space. The only reason that this one was popular was there was a school teacher on board. And what it exposed, though, was a group decision support system that was designed to stop this disaster from happening, but it didn't. And we'll look in the course as to why it didn't. Some of the problems that caused the space shuttle disaster caused the loss of space shuttle in the Columbia, years onwards. And again, what happened was that 1st of February 2003, Columbia broke up, re-entering Earth, and with the loss of all 7 astronauts. The investigation into it looked at not only the technical aspects, but the leadership aspects, and again they found that the problem was a leadership one, even though it was caused by insulation coming off that big central tank and striking the leading edge of the wing to allow superheated air, which melted the spar and the failure of the wing. It was leadership that really caused the problem. And we'll be going into that. The fact that there'd been a lot of cultural and organisational causes in NASA. They were used to getting a job done. They had relied on past success. Even with the Challenger disaster, they hadn't really brought about a lot of the changes they should have. Safety information wasn't being passed around. People who spoke up were being told, you're getting in the way of the mission. All of these things happen in organisations today. It doesn't matter how simple the organisation. They suffer the same things that NASA suffered. In the next case study that we do, we look at the Qantas Airbus 380 flight QF32 out of Singapore, where the engine exploded after takeoff. And what we take a look at there are all the circumstances behind it. The fact that after the engine exploded, the captain, Dick de Crespigny, eventually got the aircraft back onto the ground where it could have been an absolute disaster. And when we bring out what happened and the conditions that he had to land that aircraft under with all the systems that had fallen over, we see that it was truly a great feat. But it was the flight deck air crew and the cabin crew all working together that made sure that, first of all, there wasn't panic on board, but secondly, the problem was resolved and they made the best decision possible. And what we eventually come up with is good leadership helped make this situation a successful outcome. The crisis management figured right throughout, from on board the aircraft to back at Qantas to the people on the ground at Changi International Airport. Problem solving was a big skill. Management skills were important as well. Use of social media. Social media was incredibly important in this one, where people outside Qantas were finding out some of the information before Qantas found out. And like NASA, groupthink was something that they managed to get on top of in this one so that they didn't fall into the problems of groupthink. The last one we do is the Deepwater Horizon disaster. It's petroleum industry, but as you can see from this picture, when things go wrong, it's just like aviation. They can be disastrous, and 11 people died in this disaster. And of course, what we find out is that we had an explosion on the oil rig. Not only did the oil rig sink with the loss of 11 people, but we had the biggest oil spill in US history. It took months and months and months to cap that oil fill. And in the end, the investigation into it found that BP did not cover itself with glory, either in the events pre-crisis, during the crisis, and after the crisis itself. So what are some of the features? We'll look at what goes into an oil rig operation, and we can see that, like aviation, tremendous technology advances made there where it's just mind-boggling as to what they do. The blowout preventer that didn't stop the oil from coming out once the rig had the explosion. Why did that happen? The technology said it should all work on the day, but it didn't. The subcontractors who were supporting BP, who were doing the cementing of the actual drill into the ground, didn't do things right. So there are a whole chain of events that caused this accident, just as we find in aviation. And a lot of it fell down to poor leadership. Pre-crisis, BP had done a tremendous buy-up of different organisations to become one of the biggest oil companies in the world. but they took on an aged infrastructure, a lot of debt, and they couldn't afford to maintain it. They took risks, they took shortcuts. And so when it came to the crisis itself, they really didn't have a proper crisis management plan that we've studied in a previous lecture. And the CEO, Tony Hayward, we spoke about the importance of good communications during a crisis. Tony Hayward's communications were so poor that he not only personally upset the US president, but he ensured that he was removed after the crisis. And the big thing is, BP had problems before Deepwater Horizon, but they didn't learn the lessons from them. And the question we'll be asking ourselves is, will time show whether they learnt the lessons from Deepwater Horizon? So these leadership case studies, they're interesting. There's a lot of information. You get to apply all the information from the course. And the one thing that we want you to come out of it saying is, it doesn't matter what the organisation is, they all have something in common with aviation organisations. And the lessons learned that come from these other organisations helps aviation become better in itself and a safer place for people to work in and for passengers to travel with. Thank you.